Hello and welcome to 5-Minute Math. Today we are looking at the Algebra 1 concept of laws of exponents. This is standard A.11B in the great state of Texas, and we are using item number 16 of the 2022 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have this expression here, and all we know is that C is defined. So that simply means that C cannot equal 0, because if you divide by 0, it's undefined, and things just get a little bit weird. So what we need to do here is we need to look at a few different things. First, let's take a look at that D. Okay, so let's just pull that out. I've got D to the 6th power, and then I've got that to the 3rd power. So what happens when we take a power of a power? Well, if we were to look at our mathematics chart or reference material, this is what we would see. See this example of a to the m, and then we take that to the n power. That simply means we take our base, right? So that's that big number right there, that big term. And we take our two exponents, the m and the n, and we're going to end up multiplying them. So it's going to be m times n. So what we could do here is we can take our d, and then we could take our two exponents, our 6 and our 3, we can end up multiplying them. Okay, so that's going to end up being d to the 18th. All right, so I'm seeing d to the 18th, d to the 18th. Take a look at what they did for f and h. They ended up with d to the 9th. How do we get d to the 9th? Well, you would do d to the 9th if you were to add d to the 6th plus d to the 3rd. And that's not what we're doing here. That is what we call the product of powers. And you were going to need to do that if you end up multiplying the two, right? So if it ended up being like a to the m times a to the n, that's when you end up adding the two exponents. That's not what we're doing here. So if I had d to the 6th times d to the 3rd, then I would end up adding these two, d to the 6th plus 3, d to the 9th. But we didn't have that. So we've already eliminated two of those. We haven't even looked at the c. Okay, so let's end up pulling the c out of here. Okay. So it ends up being c to the 8th over c to the 2nd. Okay? So this is called the quotient of powers. This also is on your mathematics chart or your reference material. So what we look at here is if you have a to the m over a to the n. How do you handle those two? Well, you would think you divide because it looks like it's a fraction, but you actually don't. Just like when you had the product of powers, you didn't actually multiply, you ended up adding. When you have the quotient of powers, you take that base and you end up subtracting those two exponents. So what does that mean for us here? Well, we end up taking our c to the 8th and our c to the 2nd, and since they're in a fraction right there, we end up subtracting them. So this ends up being c to the 6th power. Now look at our two options here. I've got c, two of them are c to the 6th. Obviously we can't look at h anymore. Two of them are c to the 4th. Okay, so how would we get c to the 4th? Well, we would get c to the 4th if we literally just thought that, okay, a divided by 2, that equals 4, which would make sense if they weren't exponents, but that's why we have to use our quotient of powers. When you're dividing two bases, you're going to end up subtracting the exponents. So let's take our c to the 6th. We ended up with a d to the 9th, because we can only deal with like terms, so it's okay to separate it like this. And what do we end up having here? We've got our c to the 6th, and we ended up with the 18th actually. So our answer here is going to be J.